Hi, this is Team 22, and our project is smartphone-based blood pressure measurement using transdermal optical imaging technology in collaboration with Sensyne Health. An important point to be made here is that even though there is blood pressure in the title of the project has changed its scope to heart rate. The issue we are tackling is the lack of reliable, convenient way to measure heart rate without external or additional equipment such as cardiac monitors, chest straps, or smartwatches. We aim to use the hardware available, namely smartphones. The solution to this issue is a reliable, easy-to-use, non-invasive, and accessible app to do just that by taking a selfie video, available for both Android and iOS. Heart rate monitoring is essential for avoiding cardiovascular diseases. People aged over 55 are a part of the vulnerable group, and according to the Communications Market Report 2021, created by Ofcom, only 33% of people in that age group in the UK had access to smartwatches capable of measuring heart rate, while 78% of the same group had access to smartphones, which is why this is a problem that requires such a solution. Transdermal optical imaging technology is a technique that allows to calculate blood flow in the face by analyzing a video camera footage, to be precise by measuring the changes of intensity of redness which correspond to the flow of a particular blood compound. This data can be used further to obtain heart rate reading. This is what makes the whole project possible. This has the potential to have a significant impact in many domains, such as care for people with skin diseases unable to wear smartwatches to monitor their vitals, or elderly people who don't have access to wearable devices, however have access to a smartphone. This method is simple, cheap, fast, and non-invasive. We set out to create an application that works within a 10% error rate, is available for both Android and iOS, its users can authenticate into. The application should allow its users to securely store measurement data and modify or delete any user data they wish. The overall system can be broken down into two major components: the mobile application that uses transdermal optical imaging engine to measure the heart rate from a front-facing camera feed, and the backend that stores measurement data securely and is deployed in a Docker containers to the cloud, namely AWS. And these are the main technologies we have used in our project. We have managed to validate a particular transdermal optical imaging engine in combination with a smartphone camera feed to be a feasible solution to getting heart rate measurements. We have made the application for both iOS and Android. We have made a REST API that is platform agnostic, which means that the solution can be further extended to, for example, Internet of Things device, and the same backend can still be used. Moreover, the whole system is GDPR compliant. The deliverables include a containerized backend solution consisting of 7 endpoints, a PostgreSQL database, and open API documentation which allows detailed insight into the API. On top of that, we are delivering iOS and Android mobile applications that measure heart rate and connect with the backend. And now time for some demos. The scenario we present is that a new user comes to the application and registers. On the left, we can see the Android implementation, and on the right, the iOS implementation. After the sign-up was a success, we see the onboarding screens which explain how the measurement works. For iOS, the color of the frame is important. Red means no face found, yellow face found, start of measurement, green means almost there, and the measurement stops on its own when the algorithm converges. Now we sign out and sign back in to an account with many measurements to present the history screen, which is available for both light and dark mode for iOS. This is the bibliography and the end of the presentation. Thank you very much for your attention.